So if you have matching denominators on both sides, you can multiply both sides to cancel them. Or once you know they're the same, you can ignore them. So when you're doing an equation like this, the idea is, what do I need to make them equal? Denominators are equal no matter what k I put in there already. It's the top that's giving me the trouble. I need it to be 25 on top on the left-hand side. So it's got to be 7. There are other places where we do this kind of recognition, like in a trig thing. You'll have like tangent of 25 on that side, and over here you got tangent of 7k minus 24 in parentheses. And you think, oh, this is going to be awful. I got to do this arctangent stuff I haven't done in years. But you go, wait, no. This is the tangent of something equal to the tangent of 25. I just need my something to be 25 for them to be equal. So equal means they're the same as each other. So recognizing they're the same except for one characteristic means you only have to match the characteristics up and figure out what would make them match. Cool, huh? It helps because it takes the that's the idea of becoming mathematically proficient, is that you start eventually noticing out of the complexity you focus on one little piece of something. Cool, eh? All right, we have one more of those to do. Yeah, I'm going to go down here. I'm going to do it again, faster, even more efficiently. Stylus flying. That means we're really getting excited now. Okay. Let's do this thing. We need to add, I have fractions in my equation that I need to solve. Down with the fractions. So the first thing we do is we get a common denominator. If you have to add fractions, 98% of the time we want to get a common denominator and add them together. We got a trick for that. A trick pony. Here it is. This is my way of describing it to myself. I don't know if this helps you. But I'm taking the other denominator times the other numerator. So it ends up being r times r minus 4 plus, you keep the plus sign, that doesn't go away, and use parentheses, lots and lots of parentheses, r plus 4 on top, boom, over the product of the denominators, r minus 4. What's nice is it's brainless. So learning is funny. You all know of something that used to be hard and now it's easy. What happens when you're learning something is that early on, your mind is caught up in minuscule details when you aren't familiar with something. You get bogged down in all these details. But once you're learned in something and experienced in it, you don't see all the details anymore. You have a different focus. You have a different way of looking at it. Have you ever tried to explain a function on your phone to your parents? And they're like, stop, I can't follow what you're doing. You're going too fast. Does that seem like a common thing you hear? You were completely fluent. You don't notice all of the details, and your parents are like, how did you make it move? How did you touch it? How hard do you touch it? Where do you push it? You're like, it doesn't matter. Am I going to break it if I touch it like this? You know, they have all these fears of things, but those are, as you learn things, you start noticing less of the details. And this little process of adding fractions, when you make it easier like that, it's a detail. You can move on. You're like, ah, I can take care of that. Let's move on to the bigger issues. Moving on. So I did the opposite denominator times opposite numerator over the product of the denominators. Check. I'm combining like terms and distributing and having lots of fun. Yes. I'm probably multiplying wrong, and you guys are going to make fun of me, but 5 minutes after I finally do it, fine. Difference of squares. That's something you should notice. Do you see it? R plus 4, R minus 4? Notice that. It means we're going to get first term squared minus second term squared, r squared minus 4 squared. So I took advantage of something that I knew, difference of squares, right here. If you do it the long way, you'll get the same thing and you'll be fine. But it'd be good to notice that. And then I'll combine some like terms that I see right there, and we're home free. Okay, I'm going to say I'm going to write it, pretend like I wrote it. R squared plus 16, r squared minus 16. These look the same to me. That's interesting. They are the same. So if I said solve this, I would be asking you, so what exactly is r? R is it 5? You were going to say 5.
It's all real numbers.
But you don't really mean that. It couldn't be -3, right? Negative.
Except 4 and
Except 4.
Oh, I like it. All real numbers. You have exceptions though. What's wrong with 4 and -4?
Because both 4 and -4 squared is 16, and then 16 minus 16 is 0, so then you'd have 0 on it.
Ah, that's right. So it would be like all real numbers. This is fancy for within the set of all real numbers. But you can't divide by 0. There's this crazy law. Oh, now you're talking. So one thing about rational expressions is that we have to deal with division by 0 as a no-no. So you say R is all real numbers except. So I might put in here a different thing. I'm going to use interval notation. Tell me how this sounds to you guys. It's been a while. I would say -infinity to -4. And -4 to 4 works, and then so does 4 to infinity. And sometimes we put a union symbol in between those things. Have you guys done interval notation? Cool. We learn it here. This is your time. Pre-calc is where we learn all about interval notation. So what I just wrote in what seems like a mess, this means, if you heard my words as I went through it, R can be anything from -infinity to -4. But because I restarted, then it can also be from -4 to 4. Do you remember that if it's a parenthesis in an inner, it doesn't include it? It's like I'm skipping -4 on both sides. I'm getting close to it, and I'm starting up again. Kind of skipping 4 on both sides. Isn't that neato? I could say this. How about this? Anything but -4 and 4. R is anything but. How about, let's just go with that. The cool thing is that's right, and that's what we all mean. There's just really funny ways to express it that we have to learn, some notation issues. Up above is how we would express it later in our lives, but it really just means anything but -4 and 4. Nice. Muy bien. Muy bien.